Welcome back! In this segment, we'll leverage Jupyter Notebook for data cleaning and feature engineering tasks. Let's start! You may ask, what is feature engineering? It is an art of transforming raw data into meaningful predictors and is the backbone of building robust machine learning models.
So welcome back. So in previous section, we have seen that we can download data from Kaggle repository or some other open source, and that data we have seen that there were different columns, different feature vector, different variables, and we also have one target column where there was a loan status, whether it is approved or not. So now what we are going to do, we'll analyze our data, we'll see the data, we'll clean the data. So first step is what we need to do. We need to read that file from local machine. So before doing that, what we need to import pandas. So this is command import pandas as PD, and then we can create data frame. DF here represent data frame, PD means panda, and this particular command is for reading file from our local machine. Okay, so from local machine we can read our file, and then this df.describe, this is for kind of a bird eye view of data visualization, how our data looks like, what is mean, what is maximum value, minimum value, all that thing we can just see just by this command. So without doing any delay, let us run this cell. Okay, so what we can see here, we can see count. You can see the count here, count for a name column. So it means that this name column has 381 value, this applicant income has 369, 363. So what it is telling? It is telling basically that some of the columns there might be some missing value. Okay, credit history, you can see there are 351 counts. So this will deal in our next coding section very soon. So what we can do here, we can just run this very simple command df.head so that we can visualize, we can see first 5 rows of our data. Okay, so let us run this command df.head. So here it is. So here we can see that this is our first few rows of the data. So what we can see here, different column, different feature vector, different variable, and we can also see this loan status, that was our target variable. Okay, so what we can do, we can clean that data. So there are different things we need to do. When we have seen our CSV file, we identified that there was some missing value. So that missing value always create a problem. So either we can remove that row, or we can fill that missing value by different tools. We'll learn this tool in a different tutorial for sure. But at present, what we can do first, we can start cleaning the data. Another thing which is very important for this data, you can see some of the data, there are numbers. Okay, some data we can see the string value. Okay, when we analyze, when we feed our data to model, that model need data in a specific format. Okay, there are nowadays very new developments are coming. They can also convert a string to some float value, string to some ordinal value. There are different things are coming, but in most of the cases, what we do, we convert our data set in a standard format. Okay, so in our case, like for example, this dependent table 100, it's okay. There may be 1023. These are family member. Okay. Now in one places there was 3 plus this value. So 3 plus is sort of kind of new for this model. Okay, when we'll run different model, it is not acceptable. So what we need to do, we need to replace it. So what we can do, so we can replace this 3 plus by 3. So this is a command. So we can just run that. And similarly, if there is something else, we can definitely do that. So let us quickly run this command. So we can run this. Okay. Now, after running that, certainly you'll see, if you'll just again see your data by using a different command, you'll see that there will be 3, not 3 plus. Okay, now next thing what we need to do, we need to examine that how much missing rows are there. Okay, so let us see that the command is df.drop na in place is equal to true, df.describe. So we can run this command, okay, and what we can see here that basically this can replace all of our column or our rows that carries these missing value. Now what thing you can see here, what exactly you can see here, now it is having 272 rows, okay, and 14 columns, okay. But earlier there was, if you see our earlier section, here you can see 381 counts, okay. So that means we just removed our unknown missing rows where there was missing values, okay. So that means we can clean our data, okay. So next thing what we can do, we can check how much columns are there which contains this missing value. So after this cleaning step, which is this command df drop na in place is equal to true, we are removing all these rows, okay, which carries this missing value or empty cell, okay. Now when we run this command, na in columns for df dot columns df dot is na any to list. So what it is doing, it is asking Python to provide us if there is any column left which contain missing value, okay. So output, what we can see, output, this is null output. That means our data is, missing value free, okay. Now one thing I'd like to point here, in some cases it is always good to just ignore those data. This is easiest step, to ignore those rows which contains missing value, but it is not always good. In present case, we can see that there are still 272 rows, and earlier it was rows was somewhere around more than 300. So when it is 20% or so, we can remove those rows, okay. But there are other technique as well. Sometimes they count average of two adjacent value and fill that missing cell by average of adjacent value. There are other techniques such as mice or something to tackle this issue. But at present, for this tutorial, I'm just removing that missing value rows, okay. So next thing what we can do here, we can just see that how our data looks like df.head command. So if you run that df.head command, we can see still it looks good. Okay, maybe it would be much better if I could show that first row there is missing value and now there is no missing value, but anyway, this looks good. Next thing what we can do here, you can see that in this particular data frame there are two index columns. So one column, this is duplicate, okay, so we don't need that index column. So the command for eliminating that unnamed column, we can just drop that from our data frame, okay. So unnamed 0, if suppose we want to drop another column, we just need to put the name of that column, okay, this first header, and then using this command we can remove that column, okay. So quickly run that, okay, and then after that what we can do, we can just again check with this our df.head command, so we can just visualize that this is in our new, it should be df.head, okay. So when we'll run this, so we can see here in this data frame, new data frame, there is only one index column which is automatically provided by this data frame. So this looks good, okay. One thing I'd like to tell at this point, in this coding, in this sheet, Jupyter Notebook, I'm not giving this new variable, like I'm starting with df and just again I'm assigning that variable to name df. But it is always good practice that whenever we do this type of operation, we can make a new data frame, so that we can always go back and track that what exactly our original data frame was. But at this point it is okay, but I think in next few line I'll follow that strategy. Okay, now another thing is essential for us to understand. If you see our loan status, this is NYYYY value. So as I told that, it is good practice that we can change this string type value in a format which our machine learning model can read. Our Python can see this thing, so that there won't be any problem. All this urban, rural, there are string value, and this is very challenging for model to understand this value. So we'll start from changing this to some kind of numerical value. Okay, so what we can do, we can use dictionary. So the command is very simple. So df loan status, that means I'm talking about this particular column, and this loan status column, this is kind of this means that for the new, I'm just this left hand side, it's a new when it will convert it. Okay, and the right hand side, this is original column. And what we are doing this dictionary thing, and we are just mapping n to 0 and y to 1. So let us do that. And the next thing is what it is saying. It is asking that in the loan status column, what are different value, what types of value. So in this loan status column, you can see there are only two, n and y. So let's see what it says. Okay, so here what we can see that, and when we mapped it to 0 and 1, so unique value what we can see 0 and 1. Okay, perfect. Okay, so let us go to the next part. So next part, again, when we run this our standard command df.head, what we are going to see, we'll see that there won't be n and y value, there will be 0 and 1 value. So let us run this. So here we can see, okay, loan status is 0 and 1. Okay, perfect. Okay, now what we need to do, we need to just again clean that data, and what we need to do, we need to drop some column. Okay, why? Because some of the columns are not relevant for the analysis. This loan ID column, you can see there are different string value. These are basically some encrypted value. These LP0 and all that thing, model is not going to do, and they can't do any analysis. So what we need to do, we can just get rid of this loan ID, and later on, if we need to connect it with the original data frame, we can always do. Okay, but time being, we don't need this loan ID column because we can't make model using this state loan ID. Okay, and similarly, we can drop other column if that columns are not relevant. We are also dropping this loan status column, and we are creating a new data frame X. Okay, why we are doing this? Loan ID makes sense. Okay, this makes sense. We are dropping, but dropping of loan status, why we are dropping? Because separately we want to bring this loan status column, which is extreme right end, we want to put that column in the beginning. Okay, in this position. So for that, what we can do, we can just bifurcate this data frame in two parts, and then we can add it. Okay, so what we did first, we just create new data frame, that is X, which is free from this loan status and loan ID, and another data frame Y, which only contain this loan status column. Okay, so let us run this command. We can run this. Okay, so that means we have created these two data frame. Next thing what we can do, we can merge these two data frame. But prior to that, what we can do, as I told that, it is not good practice that will train our model and we just use the data frame which contains all these string. So this is challenging for model to do all that analysis and give you good result, and you may end up getting error as well. Okay, so what is good thing we can do? We can convert this string value into some dummy or some variable. So there is one thing what we call one hot encoding, where we can convert this into some different column, and then this column you'll see very soon, this column has some numerical value, and that data frame we can use in our training. Okay, so let us do that. Okay, the command is very simple. X encoded pd.get dummies X. So X is the previous original data frame, and then when we'll do this pd, obviously we need pandas module which already we imported, and then we can see that how it new encoded data frame looks like. Okay, Okay, so here we can see the beauty. We can see earlier versus this, what it did. You can see the earlier education was graduate, not graduate. What it did, it has created this education graduate and education not graduate two column, and true and false. Okay, so it is basically converting a string, and it is bringing this true false value. Okay, this true false value, which is, again, we can say that these are a string, but we can always convert this string to 1 or 0. Okay, now we'll do that for sure. But prior to that, what we can do, as I told, that in order to train our model in SageMaker, we need data frame in such a way so that when we'll use XGBoost algorithm, our first column in data frame, first column, this somewhere here, should be our target variable. Remember, when we discussed our spreadsheet, we have seen that this target column, which is loan status, whether loan is going to approve or not, that is crucial for this training. And that target column we can bring in the first value, very first column. Okay, so let us join, let us concat it. Okay, let us merge it. So for that, this pd.concat, this command is very useful. Why? So first we'll put y, because this is only one column, so y will be first one, and then x encoded. Okay, so all this will merge. X is one is along column side. Okay, so when we'll run this command, so what you will see magic, that column, this loan status column, will come in very first place. Okay, it's perfect. So let us this is okay. Let us run this. Okay, now in order to do that, first check that whether how our new data frame looks like. df.head. Okay, let us run this command. So okay, now if you see this new _df data frame, so magic, you can see here that our new data frame, the loan status, is on extreme left hand. Okay, we can ignore this index column. Okay, but this loan status column is on extreme left hand. Okay, so that is very good for our model and for clean data purpose. Okay, so next thing what we can do, as we did in the previous step, we can always convert this true false value in a numerical value, 1 or 0. So again, we'll use this dictionary thing. We can replace true by 1, false by 0. Just quickly do that, and we can, as I told, that we can, it is always good practice to make a new variable. It's not always good that you keep changing and assigning the same data frame again and again. So here what we did, I just created and assigned a new variable, new _df2. So we can do that, and then we can check that. We can check that whether this new df2 has this yes or true or false, or it is having 0 or 1. So you can see now it is 0, 1, 0 and all that thing. So we can basically see this. We can basically see that. You can see 0, 1, 0, 1, 0, 1, like all that in the numerical value. Perfect. So now what we are doing, we are cleaning our data and we are making in sort of numerical type of data frame. Okay. So one thing we can see here, when we did this one hot encoding, when we converted this string thing into this 1, 0 or true false value, in some cases we may end up getting some extra or redundant column. For example, if there is column education _ graduate, there is one extra column education not graduate. So these are basically we don't need these two. Okay, but in some case they like to include these column in their training, and in some case they don't. I mean, it is up to us whether we like this or not. So what is good practice? We can always make a data frame without these redundant thing and with this extra column or redundant thing. So we may eliminate that. Okay. So similarly, like for example, if somebody is employed no, so it doesn't make sense to include this column somebody employed yes. Okay. So we can get rid of that. But time being, let us keep it as it is. Okay, so next thing what we can do, we can always save this file. Okay, so let us just for the purpose of demonstration, we can drop one column. So like for example, we can drop this column married no and married yes. Okay, they are interrelated, so we need not to put these both. Married underscore no, and then access to 1. Okay, so let us see how it works, and then we can do new underscore df2 dot head. So we'll see how it goes. We are dropping one thing. Okay, so the new thing we can see. Okay, okay, so what we can do as I was discussing, that we can check that after dropping one column, like if we see our column here, it is married no and married yes. Two things are here, but when we drop one column married no, and when again we'll check our 5 rows here, dropping this column, we can see here we only end up getting married in this column. Okay, now at this point, what we can see here, that we do have multiple column, but most of our data looks clean, nice, with no missing value. So from here we can start thinking about using our data, and we can use that data as it is in our SageMaker environment. Okay, so prior to moving in SageMaker environment, what we can do, we can just do some sort of litmus test. So litmus test means that before going for all this detailed analysis and spending our resources in AWS, it is always good practice to check that everything looks okay, whether this data gives some result in a local machine or not. So what we'll do in next section, we will use that data. We can also see that what other thing we can do to make it much better, and then we can run some light models. We can also run some prediction. We can check that whether it is working or not. Then we can move in actual SageMaker environment.